Maxima and minima, part third. Tangent to the circle x square plus y square equal to a square at any point on it in the first quadrant makes intercepts OA and OB on x and y axis respectively, O being the center of the circle. Find the minimum value of OA plus OB. Here, these are the points where tangent to the circle cuts the axis. We consider point P whose coordinates can be found by applying simple trigonometry. OP is the radius. So this distance x will be based upon hypotenuse, that will give a cos theta. Similarly, this is y point can be found by applying simple trigonometry perpendicular upon hypotenuse, that will be sine theta. So that will give a sine theta. So we have found the coordinate of point P where tangent touches the circle. We have to find out the expression for OA plus OB. OA plus OB. So in order to find expression for OA plus OB, we consider the equation of circle and equation of tangent to the circle. X square plus y square equal to a square. Equation of tangent to the circle at point x1 y1 is given by x1 plus y1 equal to a square. So here x1 is a cos theta and y1 is a sin theta. So we put these values. So x times a cos theta plus y times a sin theta is equal to a square. We divide each term by a square. So we get x cos theta divided by a plus y sin theta divided by a equal to 1, or x upon a sec theta plus y upon a cosec theta equal to 1. If you remember, intercept from x upon a plus y upon b equal to 1 means a is x-intercept and b is y-intercept. So here x-intercept is a sec theta and y-intercept is a cosec theta. So OA equal to a sec theta and OB equal to a cosec theta. So we write them. So suppose it is S, which is OA plus OB. So that is equal to a sec theta plus a cosec theta, or a common sec theta plus cosec theta. Now we differentiate it with respect to theta. ds upon d theta equal to a times sec theta plus sec theta into tan theta minus cosec theta into cot theta. We put ds upon d theta equal to 0. So we get sec theta tan theta minus cosec theta cot theta equal to 0. Sec theta tan theta equal to cosec theta into cot theta. We put the values. So 1 upon cos theta into sin theta upon cos theta equal to 1 upon sin theta into cos theta upon sin theta. So from here we get sin cube theta equal to cos cube theta, which gives sin theta, sin cube theta minus cos cube theta equal to 0. We apply it, sin theta minus cos theta times sin square theta plus cos square theta plus sine theta cos theta equal to formula uses a cube minus b cube equal to a minus b times a square plus ab plus b square. Now this term can't be 0, so this will be 0. Sine theta equal to cos theta, that's sine theta minus cos theta equal to 0, or tan theta equal to 1, which means theta equal to pi by 4, because tan pi by 4 equal to 1. So we have got theta as pi by 4. Now we again differentiate ds by d theta to get second derivative. So if we differentiate it, what do we get? d2s by d theta 2 equal to a. Here we apply product rule. Sec theta tan theta into tan theta plus sec theta into tan square theta minus cosec theta cot theta times cot theta, and then minus cosec square theta into cosec theta. We open bracket a sec theta tan square theta plus sec theta tan square theta plus cosec theta times cot square theta plus cosec square theta into cosec cube theta. Now at theta equal to pi by 4, d2s by d theta 2 will be positive, which is greater than 0. Hence function will be minimum. Now minimum distance can be found by putting the value of theta in this equation or here. So minimum distance will be s equal to a times sec theta plus cosec theta, but theta equal to pi by 4. We put these values here. So s equal to a times sec pi by 4 plus cosec pi by 4. So both gives root 2, a root 2 plus root 2, that is 2 root 2 times a. Now let's take one more question. If sum of the lengths of the hypotenuse and a side of right angle triangle is given, show that the area of the triangle is maximum when angle between them is pi by 3. So we are given a right angle triangle. This side is x, this side is y. So this will be root of y square minus x square. Now we consider the area. So area equal to, here if we give the name, so this is B, this is C, and this is A, suppose. So area will be equal to, suppose we denote it as S. So it will be half BC times AB. We put the values. So 1 by 2 BC, BC is x into AB is root y square minus x square. Now we square it to remove square root. S square equal to 1 by 4 x square into y square minus x square. And in our question, we are given x plus y as a constant. Here length of hypotenuse and a side of right triangle is given. Given means their sum is constants. So y will be equal to k minus x. So we can put this value here. So we get s square equal to 1 by 4 x square, and this will become k minus x whole square minus x square. And suppose this is s dash. So Further, we write it, we can open the bracket. So s dash equal to 1 by 4 x square. This is k square minus 2kx plus x square minus x square. So x square will cancel out. So from here, we get s dash equal to 1 by 4 x square k square minus 2kx. So we have got the expression for s square. We can open the bracket. So this will become 1 by 4 we can keep outside. So this is x square times k square minus 2k 2k, it will become here x square is being multiplied 2k times x cube. Now we differentiate it. So we have expression s dash equal to, if we open the bracket here, so it will be k square divided by 4. So we write it like this, x square k square divided by 4 minus kx cube divided by 2. Now we differentiate it with respect to x. So ds dash divided by dx equal to, x square will give 2x k square divided by 4 minus, this will give 3x square times k divided by 2. We put this equal to 0 to get the value of k. So 2x square divided by 4 equal to 3x square k divided by 2. So if we multiply by 2 each term, so this will become 4 and then these two terms will cancel out. So, and 1x will also get cancelled. So we will get k square equal to 3k, or k minus 3 times k equal to 0, or k equal to 3. So here our purpose was to get x. Here x is missing. Uh, this x will get cancelled. 3k x is here. So here this is k minus 3x. Sorry. So here we can do correction little bit. It was xk square equal to 3k x square. So xk can be cancelled. So k equals 1k will get cancelled from here. 1k will get cancelled from here. 1x will get cancelled. So then we will get k by 3 equal to x. So we have got the value of x. Now we find second derivative. So if we differentiate this, d, this will become d2s dash divided by dx2 equals, this will become 2k square by 4 minus, from here it will become 3 to the 6xk divided by 2. Now we put x equal to k by 3. So when we put x equal to k by 3, 2k square by 4 minus 6k by 2 into k by 3. So this will come to be minus k square by 2, which is less than 0. Hence, we say that function is maximum. Now, when x equal to k by 3, then what is y? So expression is x plus y equal to k. X is k by 3. So corresponding value of y we can find, x is k by 3 and x plus y equal to k. So y equal to k minus x, that is k minus k by 3, that will give 2k by 3. Now we have got values of x and y, and we have to find out theta. So x equal to, this is k by 3 and y is 2k by 3. So if we apply here simple trigonometry, base upon hypotenuse, and that is cos theta. So base upon here base is BC. So BC upon hypotenuse is AB equal to cos theta. So BC is equal to k by 3 and divided by hypotenuse AB is 2k by 3 equal to cos theta. So here 3 will cancel out, k will cancel out, and we will get cos theta equal to 1 by 2. So theta will be pi by 3 because cos pi by 3 is equal to 1 by 2. So this was to be proved. So we have got the answer. Thank you for watching.